Hello students, today we are going to start the second chapter for physical chemistry. The first one we completed, that was the solid state. The second we have got the solution. In this chapter we are going to study about the concentration terms related, that means in which unit we can express the concentration of a solution. We'll see with few numericals like molarity, molality. Then we'll see about normality, mole fraction. Then after that we need to see vapor pressure. What is vapor pressure? Then we'll see Raoult's law, a very important law of vapor pressure. Then we will come to know about ideal solution, non-ideal solution. We'll see with the examples. Then we'll study about Henry's law. Henry's law is also there, an application of Henry's law. And after that we'll study about very important topic of this chapter, colligative properties of a solution. In this we have got 4 colligative properties. 4 colligative properties we have got. The first one is relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and the fourth one is osmotic pressure. We need to see one by one along with the expression, mathematical expression, how it has been derived, and the numerical based on each colligative properties. The numericals of these colligative properties are very important. And then we'll study about Van 't Hoff factor. Okay, so first, before we start the chapter solution, as we know, solution is a mixture in which we have got 2 components, we can say. One is solute, another is solvent. A solute is a substance which get dissolved, and the solvent is a solution, is the medium which helps to dissolve. And we have got different types of solutions: saturated solution, unsaturated solution, supersaturated solution. As we know, saturated solution means a solution in which no more amount of solute can be dissolved. That solution we call saturated solution. And if we can dissolve more amount of solute, then it is unsaturated solution. And if the amount of solute dissolved is more than the saturation value, then the solution is said to be supersaturated. Then after that we have got a term, a solubility. So solubility is defined as the amount of solute in grams that can be dissolved in 100 grams of a solvent to form a saturated solution at a definite temperature is called the solubility. So whatever amount of solute you take in gram, that can be dissolved in 100 gram of a solvent to form a saturated solution. That means no further solute can be added to that solution. At that fixed temperature we call it as solubility. Its substance has got own solubility. Next, we'll study about the concentration of a solution can be expressed in several different ways as described below. So we need to discuss few. Say for example, first if you see, we have got mass or weight percentage. Okay, mass or weight percentage is defined as the mass of the component per 100 gram of the solution. So it is given by the formula, this one. If you have got mass percentage of A, that will be mass of that A by mass of A plus mass of B, that is, this is solute plus solvent, into 100. Say for example, if you need to prepare 5% NaCl solution, then what amount of sodium chloride and water you need to take? So according to this formula, since you are preparing 5% of NaCl, you need to take 5 gram of sodium chloride and you need to take 95 gram of water, because 5 plus 95 gram will be 100 gram into 100. That will be the 5% of mass or weight percentage. Next we have got weight volume percentage. Weight volume percentage is the amount of solute in grams present in 100 ml of the solution. That was the weight, 100 gram, and this is the volume. Okay, so we can also write weight by volume percentage as weight of solute in gram by volume of solution in ml into 100. Say for example, if you want to prepare 5% of weight by volume, not weight by weight, weight by volume solution of sodium chloride, then we need to take 5 gram of sodium chloride and you need to dissolve in 100 ml of solution. That will be 5% weight by volume percentage of solution. Then next concentration term that we need to see is normality. What is normality? So normality, it is the number of gram equivalents of solute dissolved per liter of a solution. That means what is the number of gram equivalent of any solute that can dissolve in 1 liter of solution, that we call it as normality, and it is denoted by capital N. So this is the normality. Next term, next we have got the concentration term after normality. We have got molarity, a very important concentration term because we'll be using this unit in the practical. So molarity is the number of moles of solute dissolved per liter of the solution, and it is denoted by capital M. Okay, so molarity of a solution is given by number of moles of solute by volume in liter. Okay, volume in liter, that means per liter. Say for example, if you need to prepare 1 molar solution of sodium hydroxide, so for that we need to take number of moles of solute. So what will be the number of moles of solute? Say for example 1 mole. If you want to prepare 1 molarity, then we need to take 1 mole, and 1 mole will be equal to molecular weight of any substance, so it will be 40 gram, and volume of in liters means you need to take in 1 liter of the solution. That will be 1 molar solution. Okay. Next we have got, next term we need to discuss is molality. The previous one was molarity, and now this is molality. Molality is denoted by small m. It is the number of moles of solute dissolved in 1000 gram of the solvent. So it is given by the expression molality small m is equals to number of moles of solute by weight of solvent in grams into 1000. That means if you take this weight in gram, then you need to multiply by 1000. Okay. So that is molality small m. Say for example, if you want to prepare a molar solution, say for example a molar solution of sugar, then you need to dissolve 1 mole of sugar, that is the molecular weight will become as 342 gram in 1000 gram of water, because it's taken 1000 gram of solvent, is called 1 molar solution. Fine. And the next very important expression term that we need to discuss is mole fraction. Mole fraction. So let us try to understand what is this. Mole fraction, it is the ratio of the number of moles of one component to the total number of moles of a substance in the solution, and it is usually denoted by small x. Say for example, if you take a binary solutions where you have got solute and solvent, let N1 be the number of moles of solvent and N2 be the number of moles of solute. Then we can write down the mole fraction of solvent. Mole fraction of solvent means it is N1. So it denoted by x1 is equal to N1 by N1 plus N2. N1 is the number of moles of solvent by total number of moles of solvent plus solute. This formula we have studied in class 11 as well. Similarly, if you want to find the mole fraction of the solute, it is given by x2 equals to N2 by N1 plus N2, where if you add this x1 and x2, it will come as 1. Okay, so the sum of the mole fraction of the component of the solution is equal to 1. This is mole fraction. Based on this, I'm going to show you one numerical how we have solved it.